A comprehensive analysis of the 10 key principles of plastic extruders. 1. Mechanical principle. The mechanical principle is the foundation of the operation of extruders. Most single screws have right-handed threads, and in some twin-screw extruders, there are specific requirements for the rotation direction of the screws. The purpose is to increase the pressure to overcome the resistance, and the resistance mainly comes from the friction between solid particles and the barrel wall as well as the screw, the adhesion of the melt on the barrel wall, and the internal flow resistance. 2. Thermal principle. Thermoplastic plastics melt when heated and solidify when cooled. The frictional heat generated by the energy input of the motor is the most important heat source during extrusion, while the barrel heater is not the main heat source. The temperature of the rear barrel affects the conveying speed of solid materials in the feed. The temperatures of the die head and the mold are usually close to the melt temperature. 3. Deceleration principle. In most extruders, the screw speed is changed by adjusting the motor speed. When the motor rotates at full speed, it is too fast for the extruder screw, which will generate excessive frictional heat and result in a short residence time of the plastic. The typical reduction ratio is between 10:1 and 20:1, and there may be multiple deceleration stages. Sometimes, additional pulley sets are needed to adjust the speed. 4. Feed acting as a coolant principle. Extrusion involves transferring energy to unheated plastics to make them melt. The temperature of the feed input is lower than the temperatures of the barrel and the screw surface. The surface of the barrel in the feeding area is above the melting point of the plastic and is cooled by contact with the feed particles. If necessary, the rear heater may need to be turned on. 5. Material sticking to the barrel and sliding onto the screw in the feeding area principle. To maximize the conveying amount of solid particles in the feeding area of a single screw extruder, the particles should stick to the barrel and slide onto the screw. Otherwise, the volume of the channel and the inlet amount will decrease, and there may also be the generation of contaminated particles such as gels or intermittent adhesion interruptions. 6. The principle that material cost is the highest. In some cases, the material cost accounts for more than 80% of the production cost. Processors should reuse scraps and waste products instead of raw materials and strictly adhere to tolerances to avoid problems with products. Energy cost is relatively unimportant as extruders are efficient systems, and excessive energy will cause plastics to overheat and become unprocessable. 7. The principle that the pressure at the end of the screw is of great importance. The pressure at the end of the screw reflects the resistance of all downstream components. It depends on the geometry of the components and the system temperature and affects the resin viscosity and the passing speed. Measuring the temperature is very important, as overly high temperatures may cause the die head and the mold to burst. 8. Output principle. The output is equal to the displacement of the last thread plus or minus the pressure flow and leakage. The forward flow only depends on the screw geometry, speed, and melt density and is regulated by the pressure flow. There are two possible directions for screw thread leakage. 9. The principle that shear rate plays a major role in viscosity. Most plastics have the characteristic of shear thinning. Different plastics have different changes in viscosity when subjected to shear forces. Reducing the shear effect means higher viscosity under extrusion conditions, which requires more motor power. 10. The antagonistic relationship between the motor and the barrel principle. Heating or cooling the barrel will affect the viscosity of the material layer on the barrel wall, which in turn affects the energy required for the motor to operate and the current. The relationship between the motor and the barrel is not always as expected.